For the volume of revolution of curves, firstly we have to know what is this revolution of curves. What is this solid which is obtained by revolving a particular curve? For example, we have this curve here, and this is the x-axis, this is the y-axis, and this is some portion of the given curve. So this point is P, this point is Q. So what we do, we draw a perpendicular from this point and a perpendicular from this point on the x-axis. So this is the plane that we obtain. So when you rotate this curve about this x-axis, so when you move it or when you pull it towards yourself and you rotate it 360 degrees, so it would be something like this, and it would be something like this here also. So you have this whole particular solid, right? So this is the solid of revolution which is obtained, pardon me, this is also like this, right? So this is the solid of revolution which is obtained by rotating this particular curve PQ. So this is one instant. Another is if you have some, this is your x-axis and this is your y-axis, and if you have some line, say this line is given to be the one, say this point is P, this point is Q, and this line is parallel to this x-axis. So in that case, when you rotate this line about x-axis, so you would, when you move it 180 degrees, so it would be somewhere here. When you move it 90 degrees, it would be in front of you, parallel to this x-axis out of the screen, and when you rotate it 270 degree, it would be backward to the screen, right, at a distance, this distance. So ultimately what you will have this solid of revolution. And what is this solid of revolution? This is the cylinder, this is the right circular cylinder which is obtained by rotating a line segment which is parallel to x-axis, right? So this is the right cylinder. And what is this solid of revolution? This is the right cylinder. And what is this line about which you have revolved? This line is known as the axis of revolution, the axis of revolution. So this is one terminology. Another is whenever you have, this is your say x-axis, and says whenever you have some line which is not parallel to x-axis, say a line of this kind, so when you rotate this line, what would you have? You would have some structure like this. My drawing is not so good here, right? So you would have some structure of this kind, right? So it would be something like this. So what is this structure? This structure is called the frustum. This is the frustum of right circular cone. This is the frustum obtained by right circular cone. And again, the axis of revolution is this x-axis, right? So this is your solid of revolution. Another is when you have this x-axis, y-axis, and when your line segment, one of this point out of this P and Q that lie on this x-axis. For example, you have this point P lying over here on this x-axis, and another point is here somewhere. So when you join these 2 points, so this is the point. So what you will have certain figure like this. So what is this region? This is the cone. This solid of revolution, this is the cone. And here also the axis of revolution is x-axis. The axis of revolution that is x-axis, right? So here we are interested to calculate their volumes. So for volumes we can either use the triple integrals or we can integrate their areas. So we can integrate the areas. So if you take one slice of this particular curve, so if you take this disk, if you cut this cone into this two parts, so this is one disk, another disk would be like here, somewhere here. So another disk would be like this one, some other disk would be like this one, and so on. So when you add up all these individual disks, so you will cover this whole volume. So that is the idea of taking the volume by integrating the areas of this particular region. So here also what we can do, we can divide this whole solid into individual small disks having the negligible widths. So these are the disk, and when you add up all these disks, integrating means you are adding them, the disks which are very close to each other. So all these disks you are adding with each other. So once you do that, you will have the volume of that particular curve, right? And how can you obtain a sphere? You can obtain this sphere by rotating this semicircle. So when you rotate this semicircle, you would have the sphere like this, and it is not a circle but it is a 3D structure. So this is a 3D structure, so it would be something like a ball. So this is the solid of revolution, right? So is this concept okay?